So today I'm going to be speaking to you about an issue called TR-06FAIL, which was the silly branding we gave it because it seemed appropriate at the time, and other CPE configuration management disasters. I'll explain what all that means in a minute. So, oh wow, the clicker works. Who am I? I'm Darren, security researcher at XIFOS. I've been messing with embedded stuff for years. It's kind of been what kind of got me into security and stuff, was just dicking about with embedded devices and routers, was part of it. Formerly forensic student, pharmaceutical student before that, internet miscreant before that. Apparently bad, dodgy, unprofessional, childish, and a bad influence if you believe certain people's opinions of me. Not well liked by some people in the industry for hilarious reasons, mostly in the vendor side when I disclose bugs about their stuff, but hey, that's their problem. So what we'll be talking about is, we'll be talking about the TR-06 protocol and related vulnerabilities, the TR-06FAIL one, the TR-06 protocol and related vulnerabilities to that, MISFORTUNE cookie and all that, hacking ACS servers so we can take over the world, and some other miscellaneous crap in no particular order. You know, just stuff that's related. So before we begin, I'd advise, when you go home, look up, there's two talks by a guy called Tal. He worked at Checkpoint at the time, and I think works somewhere else now. One's called I Hunt TR-06 Admins, that was presented at DEF CON, and one's the MISFORTUNE cookie talk that I happened to see at 31C3. It's also worth reading through the TR-06, TR-06, and all the other DSL forum specs. There's bloody loads of them, and having a poke at this stuff yourself, because if you have a router at home from an ISP, you have all the equipment you need to have fun in your own, you have the stuff to play with this. So I guess to start, what is TR blah blah blah? They're not RFCs. They're not like the TCP/IP standard because they're not, IETF standards. They're DSL forum specifications. And the DSL forum is like a consortium of all the people involved in getting broadband to your house, and they come up with specifications and standardized stuff so that they can interoperate and, bill you and get you internet and stuff. And defines all the specifications for how to manage your broadband networks, stuff that you can follow, stuff you can implement, stuff you can probably ignore. There's tons of them. If you Google broadbandforum.org, I think it is, and then extension PDF and then TR-, you'll find there's just tons of PDFs all defining different specs. The two we're going to talk about today are TR-06 and TR-06. There's loads of others, and there's loads of good security research to be done by hopefully some of you looking at the other protocols and looking for flaws in them, because they're all absolutely disgusting. So TR-06 is LAN-side DSL CPE configuration. So DSL is damn slow lines, or DSL internet. CPE is consumer premise CPE, box on your network, the consumer premises equipment. I hate these acronyms. So TR-06 specification, it outlines this SOAP-based protocol to allow configuration of the CPE device from the LAN side. So say when you got your router off your ISP, sometimes it'd come with a CD-ROM with the broadband setup software, and you put that into your computer, you'd run it. This goes back a while, by the way. I remember doing this in like 2006. You'd click the CD-ROM and it'd go, okay, put in your settings, and it'd configure the router by magic. It's not magic, it was TR-06. And that's the link to the specification there. You can download it, you can read it, you can go absolutely bloody mad, because it's one of the most boring specifications you'll ever read through. Basically, it allows you to configure your router from the LAN side. TR-06 is the other end of it. It's the WAN side, CPE WAN Management Protocol, also known as CWMP. It outlines protocol for CPE devices being managed over WAN or internet by your ISP. And it's SOAP-based. It's all this disgusting XML. It's actually more than that. It involves soapy horribleness. It involves stun. It involves Jabber for some reason. When I was reading through it, I was like, there's a bunch of stuff in here about XMPP being used for something. I mean, there's loads of potential crap there, and it's all XML-based. It's disgusting. You can read it. It's on Amendment 5. There's probably going to be more amendments in future. So, firstly, TR-06. TR-06FAIL allows managing any setting on your endpoint, on your CPE, on your router, from the LAN side, in theory. So you can manage stuff like wireless keys, you can set the DNS servers, you can set the NTP servers, you can set whatever you want. It's got full read-write, so, you know, ACS, DNS, wireless security, and it comes with a few security requirements. So this is like how you manage and set up your router. You can change all the settings, you can fiddle with all the stuff. Yeah, it's got security things. So apparently, any action that allows configuration changes to the CPE must be password protected. Access to any password protected action must require HTTP digest auth. Blah, 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 not allowed to read passwords. You know, it seems pretty solid, and this interface should only be accessible from the LAN side. So, maybe, you know, in theory, that's all nice and lovely, but in reality, password protection, nope. Don't have time for any of that. You know, nobody's bothered to put passwords in these things. Password seems to be entirely optional. Actual credentials, yeah, you can totally read them. They're not actually obfuscated. They don't return some blank or null value. You get the real creds back out. Are they accessible over the internet? Oh, yes. This is the core problem here. This thing, which was only supposed to be ever LAN side and explicitly say, you know, pretty much do not put this on the internet, was put on the internet at scale by everyone. Oh, and it also happens the implementation sucks, so you've got bonus trivial command injection vulnerabilities, because why not? You know, you might as well tick the entire OAuth top 10 or something, you know, broken access control, clear text creds, you know, it's like vulnerability bingo. So, you know, you get all the boxes. So, obvious outcome of this disaster. Well, Deutsche Telekom had some problems. They had some quite serious problems. And they were kind of when this whole incident kicked off, and I'm sure most of you remember this incident, because it was recent, when this all kicked off, they were kind of the first ones to have a serious outage, but they weren't alone. TalkTalk, they suffered, you know, mass-scale outages, routers stopping working, device being bricked, kind of bricked, you know, where they didn't work anymore, credentials being stolen, you know, Post Office, Aircom, Demon. I mean, name an ISP, and they probably suffered some issues because of this, and it all happened all at once. And this was home users suddenly going, oh no, my internet doesn't work, what's going on? Because the software vulnerability was being exploited at scale. So, you know, what happened? Who did it? You know, is there an attribution party going on? Can we all point fingers and blame somebody? Well, actually, we can. So, it was script kiddies. You probably can't read this. No, some of you might be able to read the screenshot of some Python code there. That was the Python code used to do some of the infecty stuff. I found it on a script kiddie forum. And what it does is it sends a set NTP server request, which tells the routers, update your NTP server, which contains these magical little backticks, and you put your commands into the backticks, and suddenly they get executed on the box, and everyone has a nice day. So what they were doing was they were downloading and executing a bot to do DDoS attacks and stuff, and it was a Mirai variant called Annie. And they were dropping this, you know, en masse. And the idea was they'll build a giant DDoS botnet and they could, you know, packet things and do skiddy things. What caused the bricking, though, I'll actually go back. What caused the bricking is when you exploit this issue, if you do that and you update the NTP server bit with a shell command, what happens is the device no longer knows what time it is. And computers, you know, if you know things about computers, you know the computers really like knowing what time it is. And if they can't figure out what time it is anymore, suddenly they go haywire and just shit breaks and they stop working and suddenly no more computer for you. So devices just start to malfunction. You could factory reset them and they might start working again, maybe. So, you know, this wasn't the first time that the particular piece of software involved had issues. Before TR-06FAIL, there was MISFORTUNE cookie. It affected the same piece of software, which is the ROM pager server on the devices. And TR-06FAIL impacted the TR-06FAIL part of it, and MISFORTUNE cookie impacted the TR-069 part. Misfortune cookie allowed all sorts of shenanigans, but the most important one was you could access the device without any authentication because you could do basically write what where. You could overwrite variables in memory with other things. So you could say overwrite the check for admin password variable with lol no, who cares about the admin password, or you could change access controls and stuff. Really trivially exploited vulnerability. This is the too long don't read of it. Below is the proof of concept from a very intelligent chap by the name of Kenzo that exploits an aircom one. And what it is there's a laser on this, awesome. The first, you've got key values, right, in cookies. So you've key value. So the first one's a key to some, it's, you know, a pointer to something, and the second is what we're clobbering it with. And it's the same. Point, you know, address to overwrite, crap to overwrite it with. And what that does, what this particular one does, is it says, basically, let people in without a password. You know, don't check, you know, if they're coming from the right port. Let them reconfigure the device remotely. It'll be fine. You send this request to the router, suddenly the state of the router changes, boom, you're in. Because the software is a crock of rubbish. You know, it's just crap software. It's really poorly written. And, you know, that was one of the first, you know, when people started going, oh, we should look at TR-06FAIL. And, you know, what is it anyway? So, as I said before, it's a DSL form spec. It actually has some security in it, the TR-06FAIL protocol. So, this will be important later. But it's got security features, allegedly. It's got TLS, it's got auth. It's a complete mess. It was designed by committee. You can see, because, you know, we're on revision 5 of it now. They keep bolting crap on, and what clearly happens is somebody goes, ooh, I really like this technology. Let's implement it as part of this protocol, which manages crap. So you've got, you know, bloated rubbish. The SSL TLS is optional. I was reading through the spec, and it's like, oh, you can use SSL TLS. SSL or TLS. It's recommended. And some setups of it are really solid, where you've mutual auth, you know, you've some ISPs, the devices they ship are really good in this respect, where there's client-side cert on device, and, you know, there's mutual authentication, it's really good. Or, you know, you can just use plain text HTTP-based auth. Actual auth from CPE to ACS is kind of optional. So CPE to ACS uses basic auth, sort of. It doesn't really, in most cases. The password is sometimes important, but the username is normally like a customer ID or something. It's an identifier for the device. ACS to CPE is often, as I said, the mutual auth with a TLS client cert, or you can, you know, be really crap and use a shared secret, which anyone can leak by just taking apart their router. Again, the protocol, just like the TR-06FAIL one, it's a lot of XML rubbish. It's built on stun, SOAP, XMPP, buzzwords that, you know, some horrible enterprise developers love go here. You know, if it's disgusting and if you think that, you know, it's out of date and you should never implement it, it's probably going to be in there. The attack surface is absolutely enormous. So, you know, we know CPE end of this is rubbish. We know that your embedded device, you know, we knew this already, your little embedded router in your house. I mean, there was another talk earlier today which said the same thing. Your router's crap. Your router has bugger all security. It never will, because the vendors aren't really inclined to make secure routers yet. There's no market for it. They want cheap, they want cheerful, they want stuff you can bang out 1 million of, put them in, they work. Internet light comes on, you get the Wi-Fi's, it all is fine. So, you know, we know that, you know, CPN's, you know, crap. So, ISP end. ISPs, you know, they've got, you know, a business interest in their end of the things being secured, because, you know, their end of things have stuff like money involved, like billing. And, you know, if you go over your usage cap on your broadband, you know, they can bill you more, you know, accounting and stuff. I know on some providers you've got like 50 gig a month and then they screw you if you go over that. You know, surely they've got some rock solid stuff. Surely it's good quality enterprise software. You know, we all know that, you know, enterprise is good. Surely it can't be that bad. I mean, surely they've got this sorted. They don't want to lose money. So I'm going to go into the second act, which is the bigger part of it, in which we hack the planet by exploiting the ACS end. And I'll explain this very briefly. So we want world domination. Do any of you remember this cartoon? Pinky and the Brain? Good. So we want to take over the world, right? And we want to do it now. So we could, go after, take the Mirai approach, hack CPE, the endpoint device. We could take the Mirai approach, hack loads of routers, technically one at a time, or with our botnet, scanning, and, hack loads and loads and loads of routers. But that takes time and effort and money, and we just want them all now, and we want them cheap. So, we don't want to expend actual effort. We're lazy. I mean, I used to be somebody who was on the threat actor side of things. I used to do bad things to people. I used to hack into shit and mess stuff up. So I know that people like me are lazy. We want the easiest way to get stuff done. So we want to hack loads of stuff, but we want to do very little. So I thought, well, you could hack all the CPEs or you could hack the ACS. And in theory, hacking an ACS will be a lot faster because an ACS can send commands to all the CPEs attached to it. So why not just hack the one box instead of hacking millions of boxes? You hack the one box, then just run your script on all the millions of boxes. You get, an instant win. And the cool thing is, if you go home and play around with some ACS software, you'll discover that ACS software is amazing for botnet command and control, because that's literally what it is. You've got like run shell script on device, you've got like deploy binaries to device, you've got like recover passwords options, you've got change DNS settings, you've got all sorts of fun. You've got like all these options to, mess with, millions of devices all in one go. The world's your oyster. You can reflash firmware images, so you could, create firmware backdoors, upload them and deploy them all in one go, because that's what they're designed for. Deployment at scale, provisioning and all that. You could, turn that in its head, use it as your provisioning server is now my botnet or whatever. Or, you could just, have a think about it. I have sat down and gone, what could I do with this? And there's just infinite ideas. You go on for days thinking of all the horrible world domination you could do. Like, you could just change everyone's DNS settings in one go to redirect them all to something nasty like, shock images or whatever. The world's your oyster. Phishing. You could do phishing at scale with this. So yeah, I decided I'll audit an ACS server, or a few ACS servers. Today I'm going to talk about a particular one, which has been around for quite a while, called PRE-AUTH. And it's been slow work. Because, these are horrible, horrible, horrible pieces of enterprise software. They're enterprise grade, they're enterprise written, which means they're completely disgusting. The code's a mess, and, you go mad looking at it. So, this PRE-AUTH are about to have a very fun time. So, before I start with the explanation of all the bugs I found, here's the disclosure timeline. It's very responsible disclosure. A while ago, found bugs. Between then and now, weaponized bugs. And kind of forgot about them. Today, public disclosure of bugs. Have I contacted the people behind PRE-AUTH? No. Why? They don't deserve it. They've written this absolute shit. It's just probably some of the worst software I've audited, and I've been doing this for quite a while. It's disgusting. And, it's like, these people, they've written this to be deployed on ISPs to do, critical things, and, you'd think they put some care and attention to it, but when I look through it, it's like, oh, man, you haven't even tried. There's just no concept of, actually trying to do security at all in PRE-AUTH. So I just figured I'd drop the bugs and, let them burn, they can deal with it. Because, quite frankly, you get really sick of disclosure. Like, you disclose to a crowd, they don't fix it for 6 months, and you're like, do I drop it? Do I sit in it? Do I leave them? And I figure, if I burn PRE-AUTH, some of the other ACS vendors might perk up and start securing their stuff. So, I'm sorry that one person who probably is responsible for maintaining this project, but you're being used as the worst example in the world. So, it's been around a while. I actually think it's maintained by one person. I was having a look at it, and it seems that, it's either a very small group or one guy who writes it. It uses Tomcat and MySQL, so it's written in disgusting Java, which made me hate it even more. I refuse to program in Java, and I normally refuse to look at software that's written in Java, because no. I like to go outside. I like to not go insane. The only Java I want in my life is, coffee, not this, weird, object-oriented crock of absolute rubbish. Just no. So I immediately, just kind of felt this distaste, of just, ugh, when I looked at it. So it's the most complete TR-06FAIL ACS available for free under the MIT license. Most complete means most attack surface. I think we can all agree on that. If you've stuck on 1,000,001 features, that's 1,000,001 bits of attack surface. And in my auditing, I don't think I've even scratched the attack surface all that much. I think there is way more there. There are tons of bugs in it to be found. So if they ever actually patch the bugs that I disclose in their next release, you can just go find more. And then you can go back to hacking ACS servers and, taking over the world and, preferably get yourself a nice cat to stroke while you're doing it and demand $1 billion. So, this was the first thing I saw when I went to the free ACS site and looked up how to install it. Yeah. So they say to do this on an Ubuntu 14.04 LTS server, which is, that's a pretty old version of Ubuntu. I think we're on like 16 or 17 or, we're on one that's a bigger number than that anyways. I'm not an Ubuntu user. I had to go download this old ISO, which isn't available, I had to go to the mirror and, go back in time, find the download, and then I was like, right, now how do I install it on this, already outdated box? And it goes, do this. And it also, you see some problems here, right? Go to your home directory, wget this shell script from a non-SSL TLS site. So download a shell script over plain text, make it executable, and then run it as root, because secure deployment practice and all that. And then read on in Chapter 4 to complete the remaining 10% of the installation because we couldn't package it into a crap shell script because, reasons. And all the remaining bit is literally running a couple of shell commands. I could send them a patch for their shell script, which would mean that you don't have to do the other 10%, but they'd still be serving a shell script over, HTTP on a server that's probably trivial to compromise, but hey. So the lowest hanging fruit I found was the default login creds. Admin XAPS. Do people change this? Do people ever change default passwords? I mean, that's a question that answers itself. You can find a bunch of them in Shodan. Just put in the query. You'll need to be logged into Shodan to do a title search, but just put in title free ACS, or you can find a couple of them on Google. There's like 5 on Google. In title free ACS web. Because when you go to the logon page, for some absurd reason, it says free ACS web login. Because, it's the login for the web, or the web login, or maybe we should put an extra W in there, I should send them a patch that's like free ACS web login. You can find them on Census, you can find them, via Bing search, via, whatever way you want. Or you could just scan the internet, do a HTTP title grab. You can come up with your own way of finding these things. They're pretty easily fingerprintable. And for some reason they're connected to the internet. I'll get on to, there's a little side note on that in a couple minutes, but yeah, you can find them, and they probably have admin XAPS as the login. And another note about the login, by the way, is that, and I thought this was really interesting, when I was going through the login, when I was testing it, when I Burp Suite opened, I was like, right, I'm going to find some bugs. And I type in the admin, and then I type in XAPS, and I hit enter, and I look for where the password shows up in the data being sent from my browser to the server. And it turns out that it seems to hash, it does a SHA-1 of the password before sending it to the server. And the SHA-1 is just the SHA-1 of the password, which is also found in the database. So there's some weirdness there. There's something odd, like it's literally passing a hash to do auth instead of sending the password in plain. I have no idea why. But, it doesn't matter because you can just capture that and just ship it across. So there's some weird, smelly stuff here, and I'm just wondering, why are they doing that? It hints at something weird. So, after I logged in to the ACS server, I realized that it was actually made of XSS. It was like an XSS test website instead of an ACS. So, pretty much any parameter you can imagine will reflect back some input. It's POST-AUTH, so who cares? And most of them are reflected XSS, but some of them are persistent. Some of them stick around, and because I was an idiot when I was testing this, and every time I go back to retest it, I make the same mistake, and I don't differentiate between which payload for which parameter when I'm spamming in my XSS requests, one of them just keeps coming back, and I'm like, I'm not sure where you're coming from. I know where all the other ones are coming from, but that alert box that just won't go away, it's following me around the ACS software. I click on random bits, suddenly alert box. I'm like, whoa, hang on, where'd you come from? It's literally like damn vulnerable web app, except, it's got optional, command and control for a whole fleet of CPE devices built in, which I thought, pretty neat feature. So I've got some screenshots of the XSS bugs because everyone loves alert boxes. Here we have the first one in a get param. You can see it's like the lowest of the low of like finding XSS. We just spam something in, see what comes out, and yes, an alert box pops. Whoop-de-doo. And another one. This one in a post request to somewhere. Oh, that's the bloody one that kept popping up. I think that's the one. I don't know where that one comes from, but it just keeps coming back. And we've got more. I started numbering them at this point. I started each request, I'd record the request and I'd go, okay, I'm putting a number in for each one so I can uniquely identify my cross-site scripting vulnerabilities. Yep. So, we've got XSS, POST-AUTH, but that's not quite what we're here for. What we want for world domination are the following demands. We want it to be pre-auth. We don't want to have to crack a login. We don't want to have to rely on default creds. We want a pre-auth exploit that's no knowledge required of creds. It needs to be remote. We don't want any of this local nonsense. We need to be able to fire it at something and it just bloody works. So it needs to be exploitable over the internet. And we need a pre-auth. Now, that's already pretty much crossed off all that post-auth stuff that we found. We also wanted to give us privileged access, as in an admin role in the ACS server, because that's what we're after. We want control of the ACS server. So we want admin on it. And we also want it to be easy because, we want to do this cheaply. We don't want to spend weeks and weeks and weeks developing some absurd memory corruption exploit that works, 5% of the time because heap layouts and ASLR and all that. No, we want something that just works reliably, easily, cheaply, and that we can, build and weaponize in like 5 minutes and deploy, where we can just ship it. The minimum viable world domination plan, Pinky, and stuff. So that's what we want. And that seems like we've set, a pretty high bar, because you don't often find these things all in one basket. Some of these seem to be often quite, sometimes you get 3 or 4, sometimes you get 2. You normally don't get all 4 in one go. This time we did. This time, we hit the jackpot with what's coming up next. That can stop. We hit the actual jackpot. So, pre-auth attack surface is actually huge. It's huge, like the wall and Trump and all that. It's like bigger than his hands, so it's huge. The pre-auth attack surface is literally enormous. So, because it has to interface with TR-06FAIL clients, you've got a whole client-server model there. You've got, as well as like the admin doing admin stuff in the ACS, you also have the TR-06FAIL clients. The CPEs have to communicate with it and do stuff at the same time. So I was looking at it, and the first thing that a CPE device sends when it's talking to an ACS is a CWMP notify of, yes, hi, I'm here. And I started looking at it, and I found it was surprisingly difficult to find a good sample of one of these. Eventually I found one. And it's XML, and it's disgusting. And I went, oh no, oh no. And I went, oh no, just XML, no. So I found a demo CWMP client, and this is the nonsense that it sends. And there's just loads of parameters and loads of fields and just loads and loads and loads of attack surface to play with there. It's just enormous. So we've got all of this to play with. And I thought to myself, I hate XML. XML, Java, we're in enterprise land here. So at first I tried fuzzing the XML. I tried messing about with it, trying stuff that had caused the server to hang. I got it to cease responding. I got it just to fall over and die with various loops and stuff in the XML. I got bored of it because I hate XML. So I said, okay, I want to do something with a CWMP notify that doesn't involve having to write any XML at all or deal with this XML parser. So I immediately said the XML's out of scope. So I looked for something else I could attack. So yeah, there's the XML, but I hate XML. I don't want to play with it. You know, I just went, no, I want to do other things in my life. That example there is missing a header. It's missing the basic auth header. So I thought, don't they use basic auth to identify the devices and do stuff? Yeah. Okay. Let's see where we can get here, you know. There's possibly some fun here. So, basic auth in CWMP notify messages is used for, the password's optional. Some people require the password. Some implementations require a password. So only, you know, proper clients can talk to the ACS. But the username is actually used by the ACS to identify the device in some fields for some searches. Quite often that's like a customer number or something is the username in a few devices that are taken apart. So the username parameter is, it's put into stuff and it's messed with and it gets parsed and it gets handled. So, you know, there could be something there. And also, when I looked at the spec of, you know, what basic auth is, you know, what stuff you can put into a username field in it, it's really loose. You can stick in whatever the hell you want, so long as, you know, it doesn't mangle the HTTP headers. So we started to play around and we found something really quick when I stuck in a quote. We found a SQL injection bug, which, disappointingly, I haven't been able to reliably exploit to do anything useful yet, but that's fine. You know, that's fine, because that doesn't matter. You know, we'll find other bugs. There's a lengthy SQL query, which, when the device registers, it gets inserted. And then later on, when the admin does something, and it queries that table, the input, the single quote that you've jammed in, gets stuck into another SQL query, and because it's coming from the database, it's seen as trusted. It ends up somewhere, it ends up somewhere else, and it ends up coming out breaking something else along the way. This horrible chain of disgustingness that leads to your entire ACS server just going, nope, no, computer says no, not doing it, can't do it. And the problem is if you screw up with your SQL injection attempt, you brick the ACS. It stops working. So you got one shot. So it's like, let's not do that. Let's find something easier because I'm lazy and I'm sick of re-imaging this VM every, you know, reverting snapshot, going, oh, bricked it again, revert snapshot, sit there and wait while my computer chugs along for a bit and eventually goes, okay, we can test it again. And another one, oh, nope, broke. Okay, back to the start. So there was, you know, we didn't get lucky there, but hey, we found something else. Username, completely unsanitized, as I mentioned, and it also shows up in the UI a bunch of times from the admin side. So when you log into the ACS as admin to do your ACS admin things, you know, to cut off that BT customer who hasn't paid their bills in 6 months, to, you know, check usage, to deploy a firmware update, to fix some nasty bugs, whatever, the username field pops up and it's rendered in HTML. And I thought, what if we put an alert box in there? Seeing as it's made of XSS, and I thought, yeah, maybe we can do that. And just full disclosure, I normally hate cross-site scripting, right? I think that cross-site scripting normally is the most useless thing in the world until I started doing this. This is the first time I've made cross-site scripting actually useful and fun. Because what we do next will shock you. Probably not, but anyway, that's the clickbait title. Trivially exploitable XSS happens. So it worked. From the username that we send, we stick our script alert, whatever in, and then when the admin logs in, later on, weeks later, whatever, suddenly, alert box. So it's like, okay, so from an unauthenticated, somewhere off on the internet land, we can get an alert box into the admin session. You can see where this is going now. You know, there's some limitations. You know, we've got char length. It's in it gets passed through a bunch of SQL statements as well, so we don't want to break anything. So we have to be really, really, really careful with it. Kind of, not really. So you know, we have some restrictions, but they're not that serious. And this is screenshot of it works. You know, we got the alert box. Yay! You know, we log in as admin and it pops up and success. And I was like, okay, because we have the character length limit in there, we can't fit like an entire big blob of JS in there to do fun things. So it's like, can we load a script from somewhere remote? And if you have a short enough domain name, like, say, xss.io or something, you know, or just get one of the 3-letter ones on the 2-letter TLDs, there's loads of them available, just get something short. Yes, you can easily get your script in. Got a remote script executing. It just magically worked. We had, you know, loading in remote JS, which made testing stuff way easier. Because now what I could do is I could just start changing the JS on the remote side, relog in and see what was going on. So we started to get, you know, we're getting somewhere with this. So if we can inject remote JS into the admin session when the admin's logged in, we can probably take over the ACS, right? You know, we can probably do something. So I thought about this for a bit and I started looking, you know, is there any file upload bugs that I can trivially exploit? And I was like, effort, you know, or I could deploy something through effort. I'll just add a user. So I had to sit down, write some JavaScript. But because I was being lazy, I copy and pasted it from Stack Overflow because I had this little rule in my head. We're being the lazy world domination type, so as much copy pasta as we can to write the exploit, you know, as much laziness, as much, you know, 14-year-old from hack forums as we can get with this, you know, low-hanging fruit deserves, you know, low complexity exploits. So there's no CSRF tokens or XTest protections or any of that fancy gubbins that you hear about in the OWASP security guides because this is enterprise software written in Java and it's crap. So we can just send a post request to the endpoint that allows us to add a user. So I sat down, copied and pasted the example of send a post request in JavaScript from the first hit in Google and Stack Overflow. Went select all, copy, paste, right, edit a little bit to do what I need to do and see if it works. Because again, we wanted low effort in writing this exploit. Oh yeah, it works. So this is the test. This is the most disgusting piece of Python I've ever written. It's actually probably the worst piece of code I've ever written, but it works. You can take over an ACS system with like so little effort. So we inject our XSS payload in, and we get a response going, you know, cool, you're a device, cool, everything's fine. You just get this blob of crap back. And then we wait. We spin up our server serving our malicious JavaScript, and we sit there and we wait. And then we wait for the admin to log in. So admin logs in, you know, we get a connect. The admin logs into the ACS. The admin then loads the script from our web server, you know, standard stuff, and runs the script, and magic happens. And what's really useful, because I had the slight problem of, okay, so you've got your whole thing set up, how do you know which ones you've owned? So in the headers there's the referrer header, and the referrer tells you the URL of the ACS that you've just added an admin user to. In a later version of the exploit, I added a function to parse that out and check if the credentials we've added work. But yeah, it works. We can now add an admin user remotely by sending one post request to the ACS and then just listening and waiting for a while, and suddenly, boom, we've got an admin. Okay. And this is what it looks like. I added a nice alert dialog for debugging purposes, so the admin would definitely know they've been hacked. And we used the very unsubtle username and password of hacker. You know, just to be polite, you know, so when ACS admin logs in, they go, oh, who's this user named hacker? You know, if you want to be more stealthy, you could change it to like totally legit. Or if you want to have a bit of fun, you could change it to like GCHQ or something. Feel free to, you know, feel free to do what you like. So, you know, we've now got admin user injected, and it's been added, and we're in the admin group. Boom, worked, magic. So, you know, success. By the way, all the code, the exploit code will be released once I'm done. It'll be online on Twitter and stuff. I'll tweet it with like the B-Sides Edinburgh hashtag. So yeah. So what do? You know, we're taking over the world here. So we've got our nice bit of nasty. We scan the internet, we use Shodan, Census, Google, we find all the free ACS servers, we blast out our XSS, you know, one post request to each. You know, that'll take, I mean, just a couple of hours, you script it, let it run, boom. Then we wait a couple of days. We may be releasing an advisory about free ACS, so ACS admins have to go log into their ACS servers and check for updates. Hypothetically. Payloads fire, hack the planet. And then, yeah, we've got everything. So we've got hacked ACS servers. Now we just reconfigure all the settings, change their DNS. PayPal.com is now ours, or maybe, for all them clients, or we redirect them to, Lemon Party or something. Take your pick of all the shock images on the internet. We can reflash firmware on all the devices, so we could do persistent mass rootkitting all in one go. Suddenly you've got a bunch of firmware flash infected devices. Good luck, have fun. Imagine the cleanup cost of that. Or we can mess with billing, provision new devices. We could migrate all of them over to our ACS so the ISP totally loses control of them forever. We can do whatever we want. We're God now. That ISP is now us. We are the ISP. We're like these guys, who, by the way, have the most badass logo of all the intelligence things. It's like, yes. Nothing. You can start reaching into people's home networks, corporate networks, grabbing data. You can tell the CPE device start sniffing packets and sending you back logs. You've got basically mass surveillance in a box here, or global domination. Yeah, that's pretty much it. Have fun, take over the world, and thanks to all of these people, the organizers, yourselves, various people have helped along the way, and software vendors, because they keep me in a job. If you want to get in touch, contact details. I generally ignore email because I keep forgetting to answer it because I just suck at email. Jabber, I'm more reachable on Twitter, or this weird new Mastodon thing. I managed to blag myself a 3-letter username on one of the instances, but it'll probably fall over in a few days based on the user count. Yeah, that's it. Thanks. So that's who it is that's causing this crap. Unless it's market pressure.
Is there any way you see this getting better, or is it just a case of throw it all away and start from scratch?
Honestly, I think we need to just burn down the entire thing and start from scratch. I've been reading through the specs and stuff for quite a while. I think the first time I heard TR-06FAIL was when I was 17 or so, and I was chatting to one of my uncles who's a network engineer, and he was going on about it. He was saying that, he was explaining to me that's how the ISP was able to log into my router remotely and, fix my internet basically. And he was like, that's basically a huge back door. And I was like, oh, I should look up this. But a 17-year-old doesn't read, like me at least when I was a 17-year-old, I didn't have the patience to read through the massive bloody PDF of the spec and make sense of it. And it was only a while later when Sharatal started doing his work on it that I got interested in it again, and I went, oh, that's the stuff that I was going to mess with ages ago but got really bored and stopped. It was made interesting again. I've realized that it's screwed. There's too much crap in it. We could re-implement the whole thing from scratch way better using modern technology that's not rubbish. You could do it with JSON instead of XML, and that removes all the XML parser issues, which are never going away. You could, have proper mutual auth, proper crypto, but it's not going to happen.
Is it just fundamental to devices handed out by ISPs, or is it small business users like Cisco as well, though?
So some of those will have this stuff enabled on them. The ISP ones are pre-configured to the ISP settings. I know with at least the Microtech one that I have at home, if I wanted to allow the ISP to do provisioning, I'd have to input the stuff myself and let them have access to my device, which I didn't because lol no. Mostly it's ISP supplied stuff, but you'll find that a lot of people do configure it, or it auto configures in the setup, set up the connection nonsense. It's pretty much ubiquitous, like everywhere. There is a spec for that. I think it's 111. Yeah, it's in the hundreds, the spec for those. Yeah. Brilliant, have escaped. Escaped from questions.